All right, here's the deal. What I'm going to show you is extremely easy and extremely easy to forget. So I need you to pay very close attention and go through the thought process I'm going to bring you through. You have an XY axis, right? This is X, this is Y. You have a line. The line, let's go with a horizontal line, is horizontal. It has absolutely no slope. It's not going up, it's not going down, it's just going flat. Now, if you know that that horizontal line is at 3 on the y-axis, then you can easily label all kinds of points. I can pick any random spot, and I can label that. That's going to be 2, 3. And I can go over here, and that's -4, 3. I can go on the y-axis, and that's 0, 3, right? Because all of these values right here are the x values, right? So the x value is all over the place, and I can keep on going and pick these for all day, and none of us really want to do that. But what's really important that we see is the y value is staying constant. The y value is always 3. And when that happens, when the y value is always 3, you're going to have this flat line. And I could pick any point, let's say 5, 3, and it'll be up there on the line. And I can pick any x value, -100, 3, and that's going to be way over here, but it's going to still be on this horizontal line. And so what's going on is x can be anything. It doesn't matter what x is. The y value is always equal to 3. And so that's the equation of this line. Because x doesn't matter and the slope isn't even existent, if we say the y value is always 3, then x could be anything. It goes the other way around too. Let's say I have the xy axis, but this time I don't have a horizontal line. This time I have a vertical line. And let's say I know that this is 4 on the x-axis. Okay, so then I could pick any point again, and I could say, well, that's 5, 4. That is not 5, 4. I totally would mess that up, didn't I? The x value, let's think about this for a second. The x value follows all the way down, that's 4. And the y value is whatever's over there, and let's say that's a 5. And maybe I go here, and the x value once again follows to the x-axis at 4, and at the y value, let's say it's -3. And maybe I go right here when it crosses the x-axis, so x is 4, y is 0. And maybe I go right here where x is 4, y is 2. And what's happening is no matter where you are, the x value is always 4. The y value can be anything. So we don't even care about the y value because that could be anything. It doesn't matter. It doesn't change anything. But x is always equal to 4, and so that's going to be your equation. So what you need to do when you get a problem is you first need to identify what's going on. Okay, let's say I have this, and I know that this is at 5. Well, what I like to do is I like to say, okay, let me just pick a couple points here. Let me look at what x and y are. So x down here, let's say that's at 2. And the y value follows over, that's at 5. And then let's say on this one, the x falls down, that's at, let's say 4. And the y value is 5. And then the next one, let's say the x value is 7 and the y value is, follow it over, 5. So 7 down here, 5 on the left. And so no matter what, x is changing all the time, so that doesn't even matter. But what's staying the same is that the y value is 5, so y equals 5 is your equation. There's one other type of line that we want to talk about, and that's a really cool line actually, because this line goes straight through the origin. So here we are. It goes straight, no matter what, it's going through the origin all the time. Maybe this is it. Or maybe this is it. We have all kinds of them. It's always going through the origin. And so what happens is that equation is going to be y equals kx. So you might ask yourself, why is it y equals kx? We're used to seeing the equation of a line say y equals mx plus b, right? We're used to looking at m as being the slope of a line. So we can look at that the same way we always have, look at the rise and the run and you know, see what we get. And so that's going to be the same, except for some reason they decided instead of an M, it's going to be a K. Really, let's not get hung up on that. It's just another letter to stand for the same thing, the slope. Because look at where it is. It's right in front of X. That number in front of X is our slope. No matter if we call it M, K, or Bob, it really doesn't matter. It's always going to be our slope right there. But if we look at our equation here, we're missing the ending, right? We're missing this plus B. Well, if you look at it, anytime anything goes to the origin, the x value and the y value are both 0. And remember, this is the b value is where it crosses the y-axis. And if y is 0 there, it's crossing the y-axis 0. So it's plus 0. And if you have anything plus 0, it doesn't do anything to it. So what's the purpose of writing plus 0 here when it doesn't even affect it? There's no purpose to writing that. Remember, we try to be efficient. So then we have y equals kx. If you really don't like the k, you can write y equals mx. It's the same thing. But what we call this is we call this a direct variation. And so a direct variation is just saying that it goes through the origin, and it's y equals kx. So let's look at an example. Say that I tell you you have a direct variation with and the point 4, 6 is on that. So if I was to draw that, right, the point 4, 6 is on it, and it goes through the origin. I automatically know it's going to go through origin, so I can draw that line. I really only need the 1 point. Well, that was horrible drawing though, right, because it didn't even go through the origin, but you get the idea. There, that's better. And so we have y equals kx, and I know I don't need to write the plus b because I was told it was a direct variation. And a lot of times what they want you to do is they want you to figure out what is the equation. The only thing you need to do to figure out the equation is plug in a value for there, but I don't know it. But I can easily figure it out, right? Because I can easily figure it out. I can find the slope. I could count up and over. If I drew it out like I did here, I can count it up. How far up do I go? How far over do I go, right? Well, this is 4, this is 6, right? X is 4, y is 6. So I go up 6, and I go over 4. And by the way, I can reduce that to 3/2. So I can write y equals 3/2 x. And there we go. We have a direct variation. It's that simple, guys. It is that simple. Just draw out a little sketch, see what it is, plug it in. Now, when you're done with that, a lot of times they're going to say, well, what is the y value when x is, let's say, x is 8? What's the y value? Well, that's just a simple, evaluation problem. We know now that we have 3/2 for a slope, and we know now that x is 8. Make that 8 over 1, right? 2 goes into 2 once, 2 goes into 8 4 times. Go ahead and multiply across the top. 3 times 4 is 12. Multiply across the bottom, that's just a 1. So I know my y value is 12. Easy peasy, right? That's all you got to do.